Hello, ladies and gentlemen. This is Mr. Benzel here, and we're going to be doing skill 6.3, which is volumes. And I'm going to have a little bit of an SAT slant in that I'm going to show you what is going to be provided for you on the SAT. So the SAT really likes you to kind of look at the individual shape and the ingredients from the diagram provided. And they're going to give you these formulas. And I'm just going to name the shape for these. And the pros are that you can mainly read them from the diagram. So that's the rectangular prism. This one is the cylinder. This is a sphere. Then we have a cone. And this is pretty much your pyramid. Now, when we teach in geometry, we like to kind of use what are called the general formulas. So I'm going to put those down here below. So the general formulas for a prism is going to be just capital B times H. So this capital B gives you the area of the 2D shape. And the H is just how tall your 3D shape is, or what the height of the 3D shape is. And this is for your prism and more or less your cylinder as well. Now, the cone and pyramid, what you do is you do almost the same thing. But you're going to write it as 1/3 capital B times H. And one thing you want to kind of make sure is that capital B is not the same thing as just like the side that's the base. It's the base area. So it's the area of the 2D base. So I'm fine if you kind of look at it from the SAT perspective or more from like the general formula perspective. There's some pros and cons. Got Alice here in the video in the background wanting to show me her 3D creation. All right. Let's take a look at an example problem here. But first, we're going to do some checklist here. So I like that you are choosing an appropriate formula. You should be telling me what you are entering into the calculator, and then you're going to be substituting the key information into the formula, and you want to solve for what is being asked. So for this example here, this is your rectangular prism. So I'm going to actually kind of do this in the perspective of the volume equals to capital B times H. And this is my capital B. So my length is 10 and my width is going to be 8. So my base area is going to be 10 times 8, which gets me a total of 80. I also have that my height is going to be 15. So I'm just going to plug this in. So my B is going to be 80. My H is going to be 15. And that's going to get me a total area of 1200. And that's going to be inches cubed. Now, the SAT, what's going to happen with that, if you were to kind of use the formula, they give you like the length and the width and the height, and you could just substitute in length, width, and height. So you got like the 10, the 8, and the 15. So you could almost like read off right from the direction. So I even like to just label what's provided in the problem. All right, example 2 is going to be a reverse computation. So this one, we have bases of a prism are right triangles, and I took a picture of the base being shaded. Now this is kind of on its side. So that's an important note. No, this is on its side. So H is going to be 11. And we have a picture provided here for you. So if I want to find that my volume is equal to capital B times H, I might want to find what the area of my base is going to be. So I know that my H is going to be 11. I know that the volume is 130.9. So I'm just going to substitute that in. So I have 130.9 equals to B times H. And my H is just going to be 11. And I'm going to divide by 11, and I'm going to see what the area of my triangle needs to be. So I'm going to do 130.9 divided by 11, and that's going to get me to 11.9. And that is my area of triangle. Then I'm just going to go and I'm going to look at the triangle itself. So we know that the area is just simply 1/2 base times height, where lowercase b just kind of represents the side. So I have 11.9 equals to 1/2 times lowercase b, which is our x. And then our height is just 3.4. And I'm just going to divide by what is effectively 1.7. And then that will get me the answer that I'm looking for. So this is actually kind of a harder level volume problem, in that we're starting with the volume and you have to find an ingredient. And it's asking us to solve for x. So x is approximately equal to, at the end of the day, we have, the 11.9 divided by 1.7. So that's approximately going to be 7. Actually, it's going to be exactly 7. And we'll just say that it's units. All right, let's look at another shape. Let's go to the cylinder. So I actually like doing a hybrid of what the SAT is asking us here for. So I'm going to kind of start with that. B, capital B times H. And I know that the area of a circle is going to be pi r squared times height. And I like it like this because I can essentially read from the directions of the problem and immediately figure out what I need to put in. So my H is 5. If my diameter is 20, this means that my radius is half of a diameter. So my radius has to equal to 10. And you want to pay attention in the directions to whether they want the answer in pi or in decimal place. But when we do this, I get pi times 10 squared times our H, which is 5. And this pretty much gives us what we need. We let the calculator take care of it. I suggest when you go to Delta Math that you actually take the time and you use the pi button on your calculator. I kind of have a smartphone calculator right now that doesn't have the fancy pi button. So you can do 3.14 times or the pi button, and then 10 squared times 5 is 500. If it asks you in terms of pi, 500 pi is enough. But if I do, 500 times 3.14, your volume is going to be approximately in the ballpark of 1570.0. And that will be in meters cubed. So I do like the SAT approach for cylinders, because it's pretty obviously that base area is going to be pi r squared every single time. And you can pretty much just read the given information for that type of problem. All right. The next one is the pyramid. So this is where the general formula is going to be 1/3 times capital B times H. So that's the general formula. And it says that the side length of the base is 18.5, and it's a square base. So I'm actually just going to do an 18.5 square from the B calculation. So B is just going to be simply 18.5 squared, because it is a square. And that's going to be 342.25. And then it gives us the height, and this is like not the slant height, but the overall height from top to bottom. That's going to be 10.9. So I kind of spent a little time thinking about what my two-dimensional blueprint is going to be. And then I just find the height from the written problem. And I'm going to write this as 1/3 times 342.25 times 10.9. And then I let the calculator pretty much take care of it after that. So you just show me what you enter into the calculator. And we get 1243.5 about. Okay, let's take a look at another example. So this is a sphere. So a sphere is provided for you on the SAT. It is conveniently 4/3 pi r cubed. And I would say that there is no kind of like general formula other than that for a sphere. So you're going to write 4/3 pi r cubed. Now, the good news is you are provided with pretty much everything. So if diameter is 9.1, this means that your radius is 9.1 divided by 2. So when I do that, I get 4.55. And I'm going to substitute in 4.55 into the equation. And you can get almost a perfect computation of that. The formula don't lie. And I would say on the Delta Math, you do want to use the pi button. I'm kind of working with a cell phone calculator right now. But when we, at the end of the day, this volume is going to be approximately 394.4. It might be a little bit different if you use Delta Math and do the pi button, and it's in cubic meters. All right, the last type of problem we're going to see is a volume word problem. And this one, we're not going to baby you and tell you what type of 3D shape it is, well, explicitly. But you're going to have to read the situation and see what it is. So it's a can of soda. Obviously, a can of a soda is a cylinder. So I'm going to draw the picture here. And our general formula is capital B times H because we got two bases. And I may like to kind of like break it down a little bit more. So I'm going to write pi r squared times H. Now it gives me that my height is 9.3. And it gives me that the circumference is going to be 14.1. So they did make it a little trickier to do. Now, the good news is that we also have a circumference formula. So the circumference of a circle is 2 pi r. And I'm going to plug in 2 pi r, and I'm going to set that equal to 14.1. And I'm going to solve for r. So r is effectively 14.1 divided by 2 pi. And I would suggest that you just kind of use the exact answer that Delta Math gives you. But I'm just going to kind of use my cell phone calculator for today. And this is going to get us about 2.25 for my radius. So I'm going to write pi times 2.25 squared. And then my height is just going to be 9.3. So I'm just going to go and enter that in my calculator. So I got 2.25 times 2.25. So that's squared. And then times pi. And then times 9.3. And you'll get something approximately equal to 147.8. And that's in centimeters cubed. So always put those units in so you can make that science teacher happy. If you are kind of like drawing a picture, it's nice to include the details like the 9.3. The circumference is 14.1. So that's circumference is just basically the distance around the bottom. So that was sort of a curveball that they threw in this type of problem. So my suggestion is that when you are working on Delta Math, they will kind of give you the basic setup and formula every time that works for each type of shape. So if there's a particular shape that you are struggling with, really focus on, what is that initial setup looking like and what pattern do you see? And then you can be pretty successful with the volume problems pretty systematically. So thank you very much for zooming in, and good luck on your volume.